What is so special about mathematical objects that they should exist in their own realm? Is it that these objects are involved in tautologies or truisms that the whole of reality or the universe must encompass? It seems to be true that mathematics is discovered. So it makes sense that mathematical objects and even relationships must exist in some world. That is, there is somewhere to look to make mathematical discoveries. However, what is it that causes them to have their own world? If it is that they are part and parcel of truisms that the universe must encompass, then would the truism, "I think therefore I am," be in that mathematical world? Would I be in that world? Would all the trivial equivalences be in that world? Each of these truths are discoverable. The equivalences are true by definition. Would only the figures of geometry that could be defined and proved to exist be represented in this world? Or would it only contain figures for which a theorem exists? Presumably, it would be anything that has a definition, but if there were no theorem, why bother with a definition? So could I think up or discover a figure so mundane that it would not be the subject of any theorem, and so would not appear in the world of mathematical objects? I am of the opinion that any conceivable figure must appear in the mathematical world. If every figure exists in the mathematical world, would every tautology exist in the world? What about every definition, since we would have to have definitions for each tautology? In short, would just about every true statement that could be thought, and perhaps a few that could not be thought, have to exist in the mathematical world? If that is the case, how does the mathematical world differ from the real world? Well, I said true statements for one thing. That is different. But wouldn't the mathematical world not have to encompass false statements as well? Surely the idea of false statements would have to be included in some way in the mathematical world. Wouldn't there be theorems about false statements? I'm not sure, but if we are proving A then B, we are also proving if not B then not A. So negative statements would have to be part of the mathematical world. So what kinds of statements are we interested in seeing in the mathematical world? Well, A does not exist. The statement A is not true, A does not imply B. Surely the A does not exist can exist in the mathematical realm. The sentence statement A is not true can exist in the mathematical realm. A does not imply B is equivalent to A and not B, or A is true and B is false, which will exist in the mathematical realm. In short, it would make sense that the mathematical realm could have false statements. Now we have all the truisms and all the associated objects, such as the geometric objects that one can think of. It also includes all the negative statements and non-true statements in some form that one can think of. But here is the kicker. Why do I need a special realm for these mathematical statements and objects when reality obviously can contain them once they are discovered? I.e., mathematics is more discovered than invented, but its principles are based on axioms and definitions, in effect, which the real world handles quite well. Therefore, it makes sense that the axioms and definitions exist in at least approximate form in the real world. If so, perhaps the mathematician not only discovers but creates to a small degree. If not, then there must be a mathematical realm, it would seem. It just seems a little inefficient that there would be a mathematical realm and a physical realm that contain the same material. This is the best argument I think I can make for the non-existence of a mathematical realm.